All right. On this one, we're going to do A, the local extrema, B, the intervals on which this function is increasing, and C, where it's decreasing. All right, so in order to find an extrema, or in other words, a max or a min, if you want to find a max or a min, remember that the derivative right here is 0, and the derivative right here is 0. So it's going to be where the derivative is 0, or remember something like this could happen, and this could be a max or a min, and that would be where it's undefined. So we need to look where, that's where the derivative is undefined. So we need to look and figure out where this derivative is going to be 0. So first of all, I need to find the derivative. So g prime of x equals. So it's going to be this times the derivative of this plus this times the derivative of this. Now the derivative, so if u is x over 1/3, the derivative of this is going to be 1/3 x to the negative 2/3. Or in other words, 1 over 3x to the 2/3. I'm going to leave it in exponential form for right now to make my math a little easier. So I need to multiply this by 1 over, and if I'm going to do 1 over, I might as well just put it all over 3x to the 2/3. All right, now, I need a common denominator if I want to put these together. So what I'm going to do is I'm going to multiply x to the 1/3, and I'm going to multiply it by 3x to the 2/3 over 3x to the 2/3. And then we're going to add that to x plus 8 over 3x to the 2/3. Now remember, when you're multiplying two variables with exponents, so like if I have x squared times x cubed, all I do is add the exponents. So it's going to be 2 plus 3, in other words, x to the 5th. So in our situation, it's going to be x to the 2/3 multiplied by x to the 1/3. So this is going to be x to the 2/3 plus 1/3. And as we know that 2/3 plus 1/3 is actually just going to be 1, so it's just going to be x. So that makes things a little nicer. So we end up getting 3x plus x plus 8 all over 3x to the 2/3. So this is going to be 4x plus 8, and now that I've gotten my common denominator and everything's fixed, I'm actually going to rewrite this as the cube root of x squared. So what we need to do is we need to find where this is 0 and where it's undefined. Well, where the zeros are, we know it's the top of the function. So I'm going to set the top of the function equal to 0. And if we solve that, we get 4x equals negative 8, so x equals negative 2. There's one of my points of interest. And the other point of interest is going to be where this is equal to 0. Divide by 3, you get the cube root of x squared equals 0. I cube both sides, I get x squared equals 0. Square both sides, I get x equals, well, plus or minus 0, which is still just 0. So my 2 points of interest are going to be 0 and negative 2. So I'm going to plot that on my number line. Now, in order for it to be an extrema, remember that the derivative has to go from positive to negative or from negative to positive. If it goes from negative to negative, it's either doing something like this, or it might be doing something like this, but it's not going to be a max or a min. So we got to do our sign chart and figure out what everything's going to be. Now remember, since we're trying to see the sign change of the derivative, I need to make sure that I use a sign chart of my derivative. So let's erase everything so we're not so confused. I have my points of interest on my graph, so I'm going to erase the points of interest as well. And I'm going to take this, put it over here. So now I need to plug somewhere something negative over here, something over here, and something over here. Now, I'm going to plug something like -3 into here. So if I plug -3 into this, I end up getting 4 times -3, then plus 8, divided by 3 times the cube root of -3 squared. Well, instead of worrying about this down at the bottom, well, -3 squared is always going to be positive, so the bottom's always going to be positive, so I'm not going to worry about that. 4 times -3 is -12, plus 8 is still going to be negative. A negative divided by positive is negative. So if I plug something in here, and if you don't really know what I just did, just plug into your calculator this whole thing, and you'll find out that it's negative. Then I am going to plug in -1 into here, into my derivative to see what the sign is going to be in between there. So we're going to get 4 times -1 plus 8 all over 3 times the cube root of -1 squared. Now the nice thing about using a -1 is it's actually really easy to square it and cube root it and everything. So this becomes -4 plus 8 divided by, now -1 squared is 1, cube root of 1 is 1, 3 times 1 is 3. So I end up just getting 4 over 3, which is positive. So that's going to be positive. And now I'm going to plug something bigger than 0. So I'm going to go g of 1. And that's going to be into my derivative. That's going to be 4 times 1 plus 8, all divided by 3 times the cube root of 1 squared. Well, 4 times 1 plus 8 is 12. And then this is going to be 3 times 1, which is 3. So that's 4, which is positive. So I'm going to make this positive. All right, now I have my sign chart. Now let's interpret it. So now we have the sign chart of the derivative. We know right here there is going to be a max or a min, mainly because we changed signs. So we go from a negative slope, to a positive slope, which means I am going to have a min here, and then something weird's going to happen there. Now, I start off with a negative slope, which means it's going to come off from this direction, and then I'm going to have a positive slope this whole way, so there's going to be a up here. So this is going to be an absolute min. So we are going to have an absolute min of, now in order to find what the absolute min is going to be, I need to plug -2 into my original function. So if I plug -2 into my original function, I end up getting the cube root of -2 multiplied by -2 plus 8, or in other words, I end up getting, now a negative, cube root of a negative is negative, so I can actually pull out the negative of this cube root. And then this is going to be multiplied by 6. So it's actually going to be -6 cube roots of 2. So that is going to be my maximum, my absolute, well, my minimum, right, my minimum. So I'm going to have an absolute minimum of -6 cube roots of 2 at x equals -2. Now, that is going to be A. B is going to be, where is the function, where is the interval on which the function is increasing? Well, increasing means it's going to be the derivative is positive, and the derivative is positive from -2 on. So I'm going to say it's going to be from -2 to infinity. And then C is going to be where is it decreasing, and it's going to be decreasing from -infinity to -2. Now let's look at the graph a little bit and see what's going on. So there's our graph. And if you notice at -2, we do have an absolute min, and it is decreasing from here to here, and then it's increasing from here to here. But if you notice right here at 0, because it went from positive to positive, we didn't have a max or a min. We had, it looks like an undefined slope right there, and that's actually makes sense because right here it was undefined. So there, let's look at the graph.